Assalamualaikum, my name is Nur Hazwani Izia binti Suhami, metric number CFY90014. I will present about introduction. For problem statement, the primary purpose of wastewater treatment plant is to protect individuals and the environment from hazardous and poisonous components containing in wastewater. Because of the natural process of cleaning water is overburdened, water treatment plant will work to speed it up. This facility cleans wastewater in various ways before releasing the purified water back into the environment. In this project, a new development area are located at Perak. The type of development of the area are shown in the table 1. The type of development, which is resident house, guard house, multipurpose hall, surau, maintenance office, service laundry, public toilets and swimming pool. The total PE for the area is 4,630. The objective is first to remove as much of suspended solid as possible. Second, to reduce or remove the pollutant and kill a disease-causing organism. Third, to improve the quality of wastewater. The overall wastewater treatment process is start from influence, then go to bus screen, next grid chamber, next skimming tank, next primary settlement tank, PST, and lastly effluent.
For the design of bus screen, firstly we need to find the value of average daily flow, peak flow factor and peak flow design. Based on the given criteria to design the bus screen, we need to calculate the value of the approach velocity, the number of bars, the velocity through the screen bar and the head loss through the rack. Then we can get the value of quantity of screening. After that, to know the value of bus screen, we need to design perforated plate and compute the inclined length of the bars. Lastly, from all calculation, we will get the length of the screen chamber, which is 2.5 meter.
Assalamualaikum and hi, my name is Nur Hazwani Izia binti Suhami. My metric number is FY90056 and today I would like to present our group project for design of grid chamber. This is the provision requirement of grid removal system, which is the requirement divided by 3, which is duty, standby and bypass, and the number of unit process, which is below than 5,000 PA or more than 5,000 PA. Next one is the design parameters for grid chamber. This is the design parameter we get from the guideline. Next one is the design. Our project uses the design of horizontal flow grid chamber. This is the step for the design grid chamber, which is A. Compute the cross-sectional area, B. Compute the length of the channel, C. Compute the depth of the channel, D. Compute the net volume or capacity of the channel, E. Check for SLR and centimeter velocity, and the last one is design summary and dimension of the grid chamber. This is the example for a figure of plan of horizontal flow grid chamber. Next one is our assume of project, which it assumes width for 3 meter, freeboard 0.2 meter, depth of grid connection for 0.2 meter, and the VH we refer from the guideline we get for 0.2. The check for the calculated settling velocity. With the allowable settling velocity, we get the 19 million per day. Multiplied by 1 day, we get for 0.0002 meter per second, which is below the 0.2 meter per second, the allowable value. So this is the design of our project is acceptable. And this is the design summary for our project, which is we use number of channel for 2, total number of channel length for 38 meter, total depth of channel 0.43 meter, width of the channel B for 3 meter, and detention time T for 3 minutes, including the thickness of the dividing wall between two channels 0.5 meter. The overall dimension of a grid chamber are 38 meter multiplied by 3 meter plus 3 meter plus 0.5 meter for base and multiplied by 0.43 meter for depth as shown in the figure. This is our plan view layout for our grid chamber. That's all from me.
Hello, my name is Nur metric number CF1097. I'm going to explain about the design of sedimentation tank. Firstly, we are going to follow the design parameter for primary sedimentation in the guideline and calculated our QP is 4,136.18 meter cube per day, and the assumed number of tank is 3 units, SLR 45 meter cube per meter square per day. Width is 5.5 meter, height of the depth is 3 meter, and the suspended solid in wastewater is 250 mg per liter. Next is the design summary that I have calculated. This is the width is 5.5 meter, height of the depth is 3 meter, and length is 6 meter. The mass of primary sludge generated from SI is 156,279 kg per day, and the volume for primary sludge produced is 2,530 33 meter cube per day. And lastly, the capacity of such pocket is 422 meter cube.
Biological treatment. Biological wastewater treatment is designed to degrade dissolved pollutants in the effluent by the action of microorganisms. This element enable microorganisms to live and reproduce for longer periods of time, and pollutants serve as nutrition. However, water solubility and non-toxicity of the contaminants are requirements for such degrading activity. The degrading process might take place either with oxygen present aerobic therapy or without oxygen anaerobic treatment. The combination of processes chosen for each individual case depends on the specific quality of the effluent grade to be treated. Anaerobic processes are used for the treatment of more polluted effluents, such as effluent from paper converting plants. Anaerobic microorganisms carry out their metabolism only in the absence of oxygen. Anaerobic processes are characterized by a small amount of excess sludge produced and a low energy requirement. This process is very different compared to aerobic process, which is in conventional aerobic biological wastewater treatment processes. Oxygen is usually supplied as atmospheric air either via immersed air bubble, diffuser, or surface aeration.
Next, I'm going to continue with the proposal of the sludge management. This is the chart of the sludge processes until the disposal. Firstly, through the process of thickening, the surface area calculated is 1012 meters squared and the depth is 25 meters. The second process is the sludge stabilization or digestion. It happens in two stages. Firstly is the anaerobic digestion by acid forming bacteria. The dry solid sludge is heated and mixed in a closed tank during the first step. Then it produces a methane gas and it goes through the second tank where it is transformed by more bacteria to produce a combination of carbon dioxide and methane depending on the quantity retrieved. Next, it goes through the sludge conditioning, which sulfuric acid, alum, chlorinated copper, ferrous sulfate, ferric chloride with or without lime, and other components have all been utilized. The calculation of the solid and release of the absorbed water are the consequences of chemical conditioning. The fourth process is the sludge dewatering. It uses the centrifuge machine. Dewatered sludge typically includes a considerable quantity of water, up to 70%. Next is the volume reduction process. The process is used or wet oxidation is a result of wastewater treatment that uses high pressure and temperature to oxidize contaminants in liquid form. WAO operates in temperature between 1 to 5 and 300 degrees Celsius and at pressure between 0.5 to and 20 megapascal. The wet oxidation increases the sludge solid capacity to settle and the effectiveness of the treatment. The last process is the disposal. Depending on its chemical makeup, the sludge can either be buried underground in a sanitary landfill or utilized as fertilizer once it has been successfully dewatered. If the sludge is too poisonous to be recycled or buried, it can simply be burned up and turned into ash.
For the disposal method of secondary effluent, our group project used discharge into natural water. This is the most common disposal practice used in the development due to the lowest associated cost in comparison to other conventional methods. The removal of significant contaminants from the wastewater is accomplished by this treatment facility, getting rid of as much suspended solid as possible before releasing the effluent back into the environment is the aim of wastewater treatment. The effectiveness with which energy, nutrients, and other chemicals are recovered from treatment plants has been improved by more recent technology and methods, assisting in the development of sustainable market and serving as a source of income production for wastewater treatment facilities.